Welcome to qnawire.
Hello everyone, here it is given a curve in a speed track having the radius 1000 feet and rated speed, that is also called optimum speed, 120 mile per hour or 176 feet per second. If racing car starts skidding on the curve when traveling speed is 180 mile per hour, so maximum speed is 180 mile per hour, that is 264 feet per second. To negotiate the curve without skid, calculate angle of wanking, coefficient of friction and minimum speed to negotiate the curve. Let us start solving. Normal acceleration of the car will be v square by rho. Now drawing free body diagram of the car. Just symbolic I am drawing here of the car. Here it will be normal reaction, weight of the car, just a moment, weight, friction and mass into normal acceleration. Taking this is to be x-axis and this we will consider y-axis. Summation of forces along x-axis, if we take the friction force plus component of weight in the direction of x, we will get this angle. Already we know theta, w sine of theta is equal to ma cos of theta. So from here friction force we will get acceleration is v square by r, so mv square by rho cos of theta minus weight is mg sine of theta. Say equation 1. Taking summation of force along y-axis, so it will be n minus component of weight in the direction of y-axis sine of theta, that will be ma sine of theta. So you may write n to be equal to mv square by rho sine of theta plus mg cos of theta. This is equation number 2. First case, to find angle of wanking, speed is rated speed, which is given 176 feet per second, and n will be 0 or friction force will be 0. So dividing equation 1 and 2, or you may write from equation 1, F is to be taken 0, m rated v square by rho cos of theta minus mg sin of theta. So tan of theta we will get v rated square upon rho into g, that is 176 square. Radius is 1000 into g is 32.2. So tan of theta we will get 0.96199, that is angle of anking to be 43.9 degree. This is the answer of part A. Now part B. In part B we have to find coefficient of friction mu. So this is the case of sloping outward, that is F should be equal to mu n. So mu is equal to F upon n. Dividing equation 1 and 2, we will get v square cos of theta minus rho into g sin of theta upon v square sin of theta plus rho g cos of theta. Here v is given at which sloping will start, that is 264 feet per second. Substituting here 264 square. Angle of anking we have obtained 43.9 minus radius of the curved path is 1000 feet. G is 32.2. Angle of anking again 43.9 divided by square of velocity at which sloping may start, sine of 43.9 plus rho is 1000 into g 32.2 cos of 43.9. So it will be 0.390, that is coefficient of friction. Now C part, we have to find minimum speed. Minimum we required. So for minimum speed, F should be minus mu n. So minus mu is equal to v square cos of theta minus rho g sin of theta upon v square sin of theta plus rho g cos of theta. So by using this equation, speed can be written as, solving our equation for speed, that is minimum speed, it would be rho into g sin of theta minus mu cos of theta divided by cos of theta plus mu sin of theta. Substituting the value, radius is 1000, g is 32.2, sine of 43.89 minus mu 0.390 cos of 43.89 divided by cos of 43.89, mu is 0.390, sine of 43.89. So we will get minimum speed by which vehicle can negotiate the curb path, and that minimum speed is 78.8. Here you will get 105.62 feet per second, and in terms of miles it will be 78.8 miles per hour. That's all for it. Thanks for watching it.